Alrighty, guys, welcome back, everybody, whoever's watching. Today, we're going to talk about series parallel circuit. I'm going to cover it a little bit, and then we're going to talk about reading schematic diagrams. This is very important. As soon as you can read schematic diagrams, you can pretty much fix anything. I fixed washer dryer. I fixed a proof for me and a student. If you know how to read diagrams, you know how the sequence of operation. All right, let's get going. We have a lot to cover today. Basic ladder diagram, introduction, reading schematic diagram. Alrighty, so looks confusing, guys. I know a bunch of lines and stuff, okay, but I try to make things as simple as possible. All right, so we have here a light switch. We have plug, switch, and light. Okay, easy peasy. We all know what this does. So there's your line and your neutral. Your line is right here and the neutral. The switch is down there and the lamp is over here. The lines goes up and down like this, L1 and neutral. I know they go to nowhere because this ladder, the whole idea of a ladder diagram makes it easy to understand what goes where. It's a roadmap. Make it easy to understand, okay? So it's like pretty much everything cut in the middle and split. Cut in the middle and split. As you can see, in reality, the plug is together. Boom, but the diagram, L1 on one side, neutral on one side, switch is over here, lamp is over here. Okay, now we have series. When we talk about electrical, series is, think of a TV show. Shows go in series, episode 1, 2, 3. So right here we have the switch is in series with the load. Okay, hope it makes sense. That's what series is. Important to know the term series and parallel. Okay, think about it. Now I added another light bulb. Okay, so now we have two light bulbs in parallel, right? Makes sense. So then there's another subject about series and parallel circuit. What happened to the current? What happened to the voltage? But I'm not going to cover that for now. But it's important to know the terms series and parallel. Okay, so we have right now two lights in parallel in series with a switch, or a switch is in series with two lights in parallel. Either way. Okay, let's move on. So when you go to an AC unit or any machine, it's like spaghetti, wires going everywhere. But then by looking at a diagram, one shows you the ladder, uh, easy to figure out what turns on what. And the other one on the right side shows you the location, the connection. Okay, so as you remember last slide, we have contactors, we have coil and contacts. Okay, and then when we apply voltage, we create a magnetic field, and boom, I covered that last video. Important to understand EMF, and we have coils, single pole, double throw, etc. Okay, and when they're energized, they normally open will close, normally close will open. Because the EMF field, that was last video already. So now we have heating thermostat because it is above the line. So if you look at my hands now, right? There's the heating thermostat, right? It's a heating thermostat because as temperature falls, thermostat is gonna go down and close. That's why it's above the line. Okay, when it gets hot, it's gonna open. That's why it's above the line. That's your heating thermostat. And that's your cooling thermostat. The other way around, it is below the line, right? When it gets cold, opens and turn off system, or when temperature rises, will close, turn on the system. Okay, let's move. These are terms you need to know. Closes on temperature rise, closes on temperature rise is cooling thermostat, while open on temperature rise is a heating thermostat. Okay, let's move on. Relay, compressors, and transformers. Okay, now basic diagram. We have L1, L2. Sometimes they call it neutral, sometimes they call it L2. Okay, so there's other ways to name things. So we have one load in a series with one switch in series with a load, excuse me. Okay, switch and load, figure that out. Switches, they pass the power, loads consume the power. Okay, so now switch is closed, load's on. Switch is open, load off. Okay, Let's move on. Now we have contactor. So in here, this is a simple diagram. At the bottom is now it's split. Contacts at the bottom, but the coils at the bottom, but contacts on top. Okay. And this is your blower relay, the blower relay coil at the bottom, but the contact on top. And that's together. So now when the switch closes right here on the left, that will have a complete circuit to the compressor contactor, turn on the contacts on, and the blower relay will turn on the blower motor, close the contacts. Easy, easy peasy. And we talked about transformers last video. We'll cover, watch the last video. Okay, so there we go. Now we added a thermostat and a transformer. So the the R indoor fan relay thermostat, as you see on the left, is auto. Nothing happened. When when you turn on the switch on, the indoor fan comes on. Turn on indoor fan relay. Cooling mode, the cooling thermostat, fan switch auto. So now cooling mode, thermostat closes here. We'll turn on both indoor fan relay. And so two things, you're gonna be in cool mode and thermostat gotta rise. That will turn on indoor fan relay, compressor contactor, and crankcase heater will shut off. Notice here, crankcase heater was on. When the system is off, you need the crankcase heater now off. So look at the compressor now. It goes to the high pressure, low pressure. So we have high pressure, low pressure, and looks like safety switch in series with the compressor. Okay, let's move on. Now, this is have nothing to do with HVAC, but to show you how many ways you can wire things. So, okay, so there we go. Boom, black, blue, and green. So this one, another example. Black, blue, and green. You do it step by step. Black first. So here we go. From the on-off switch, it goes to relay 1 and out to relay 2 and 4. And then next one, next one, next one. It's just a quick example. I'm gonna skip that quick because this is good to know, but it's move on to the refrigeration. So when I was teaching, I'll give this to the students and then they have to connect it together. Okay, but by looking at the ladder diagram, they go put it from ladder, they transfer to this. And we're gonna do it today, right now. Okay, ready? That's a transformer, okay? And as you remember the transformer last video, we had one side is the secondary YMB 24 volt. One side is the primary common, common black, red, or orange. Look at the video last time. Next, we have indoor fan relay. There it is in the diagram. This is the coil. The contacts somewhere else. The coil of the compressor contactor. If you notice, there's a mistake in the diagram. There's always mistakes. Look at T1, L1, T2, L2, and comment. This whole thing should have been moved up. This is the coil. Where T2 and L2 is actually the coil. T1 and L1 is actually T2 and L2, and the top one is T1 and L1. I'm sure I left it accident like this on purpose so you can know sometimes there's mistakes, but you know what a contactor diagram is and what it does. That's how it's wrong, not here. Okay, let's move on. Next is the gas heating relay. Excuse me, gas heating relay coil. Contacts are somewhere else. Then the transformer, thermostat, excuse me. Okay, now, I'm not for the compressor and condenser fan motor in parallel, hermetic and outdoor fan motor. We're just gonna put a light bulb for now because another class I'm gonna do the potential and current relay and capacitors run and start. It's just too much right now to put it all in one place. Okay, we have the indoor blower motor will be fun. So let's move on. There's the T1, T2. Excuse me, T1, T2. Yes, there's T1, L1, L1, T1, L2, T2. And there, again, the gas valve also, we're gonna put a light bulb. Now, and the motor and the blower heating relay. Blow, I'm sorry, gas heating relay. Now, the motor is more complicated. I'll cover motor in details when I do motor class. But as you can see, the motor have high, low, run and start. I'll cover it in details when we do motor class. Then the last thing is the heating switch. Okay, let's get going. We have a lot to cover. So this is connection. This is ladder. And we're gonna finish with this. Looks like a spaghetti, huh? Sure, it's a spaghetti plate. So we gotta go from this to this for the, okay, and the high voltage. Let's get going. Take a sip of coffee. Alrighty. So it doesn't matter which way you go, left or right, right or left. There is no, when it comes to wiring, you can do whatever you like. There is no right way. There is no, there's many right ways, but there's wrong way. Okay, so connection one. Excuse me, I didn't say that right. There's only one right way, there's many wrong ways. Okay, so first connection, we look at the transformer between 1 and R. We have two connections, 1, 2. So we get the transformer secondary Y connected to R. That is a connection, 1, 2. We'll get a wire from one place, hook it up here. I don't care if it goes up and down, left and right, as long as it connects. Next, we have 5 connection now. This is the secondary. We're gonna do secondary first. This is now S2 or common. We have 1, 2, 3, 4, 5. All right, everything goes to the common. 2 ways of doing it. Either put a terminal board here, and there we go. 5, 4, 3, 2, 1. And everything is on the common. Compressor contactor, the indoor fan relay, gas heating relay, and the number 1, the secondary of the transformer. That's 5 connections and common to the thermostat. Okay, and there's a common to the thermostat in case it have batteries. In case it have batteries. Okay, now next, 2 connection, the W for heat, easy. W goes to heating relay, the gas heating relay. There we go. Connection between W, the purple to 2. Next, cooling relay connects to the compressor contactor. Yellow, 1 to 2. 2 compressor contactor right here. Next, we have 2 connections. This is for the fan. G to the indoor fan relay, 1 connection, easy. Excuse me, 2 connections. There we go. G to indoor fan relay. Indoor fan relay coil. All right, now we move on to the high voltage. Woo-hoo. Up to the high voltage, or also known as the load circuit or the high voltage circuit. Alrighty, so we have L1 connects to pretty much a lot of things. Compressor contactor, the gas heating relay, and the common coming in, indoor fan relay, and the common coming in number 3, and the transformer primary. And there it is. Okay, there we go. Power comes in from somewhere. That's what's missing on line for the power. The power comes in somewhere, anywhere connects to 1 or connects to 4 and goes out. Oh, there, power's right here. There's the connection. 1 and 4, power comes in there and goes to 2 and 3. There we go, black. Alrighty, next. The neutral side, or L2. 1, 2, 3, 4, and a little tricky here. 3 and 4 is tricky. You gotta remember, it looks like they are in series, but they're not. They are in parallel. All right, there it is. There's your neutral, or 3 and 4. Neutral goes to 3 and goes to 4 and goes to L2 and goes to, oh, okay, and goes to B3, just like the diagram. Okay, B3, compressor contactor, the capacitor, and transformer. And transformer, where's transformer? Right here. Okay, number 5. All right, let's move on next. Now we have 3 connections. This is from the compressor contactor to the compressor and the outdoor fan motor. There it is in the gray. Number 1, from the T1 goes to number one and number one. And other side, T2, 1, 2, 3. Same thing, but it's T2. Okay, now we have two connections here. And this is the connection from the number 3 of the gas heating relay to the gas valve. Okay, and there it is, gas heating relay to the gas valve. 1, 2, the 3 doesn't belong there. Then we have two connections. The last but not least is number 3 switch go to the high speed of the indoor fan motor. Okay. And there it is. And we end up this. Looks like a spaghetti. Now next, this is ladder and pictorial. Boom. So we have, again, one is connection diagram, one is ladder diagram. All righty. And this is the same thing. I just zoomed in. Which one is easier to read? The only thing is outdoor unit is not shown. So we have the, let's start again. Thermostat. At the bottom tells you thermostat. Again, it's in two locations. On top, in the connection diagram and the schematic diagram. Okay. It's just a schematic diagram, easier to read, ladder. Thermostat, RGW, 24 volt in, out G to fan, W out to heat. Okay, this one doesn't have a common or S2. It must be an old one, Mercury, or maybe a new one with battery powered. I'll cover the common when it's used when we deal with thermostats, especially with heat pump thermostats. So this must be an old Mercury battery powered. Over here, you see the G, R, W, and Y. There's no common this one. Okay, so everything is here except the outdoor unit. The outdoor unit is outside. This is only showing thermostat and indoor unit. All righty, next. We have the gas valve, automatic gas valve. There it is, there it is. The transformer, the one at the bottom is incorrect because it is, it's a big one, multi-volt. The system is 120 volt. And there we go, the fan limit switch. It's two parts, fan control, fan limit switch. As you can see, fan control, fan limit switch, limit switch, fan control, limit switch, fan control. We'll cover it in details when we do heating. And one is normally open, one normally closed. That's why it's important to know the terms. Next is the single pole double throw relay. This must be a small blower to have a small little relay. But again, the system is 120 volt air conditioner. So it must be a small furnace. So it must be a small furnace. Yeah, maybe. We don't know until we look at the nameplate of the unit. But there's the diagram there. And okay, next. Now the blower motor, there it is. And again, the blower motor, you can see here, one line going to low speed, one is going to high speed, and one going to common. And I'll cover motors in details when I do motors. Next is the switch. This is the door switch, safety switch. So when you open the door, unit shut off for safety. But why is it in the open position, huh? Another mistake, people. Always mistakes. Right now, the unit ain't gonna run right now because the door switch is open. It should be closed. Alrighty. So schematic diagram, connection diagram, which one is easier to read? Definitely the ladder diagram, a lot easier to read. Okay. That's another example, split system air conditioner. L1, L2. That's a crankcase heater. It's optional. I'll cover it. We don't need it here in Florida, but some places we need. I'll cover it later, another class. And there's your compressor with common run start. That's how it's supposed to be. And that's your, it looks like compressor contactor. It looks like single pole, single throw. I mean, one pole. And there's your dual capacitor for the fan and condenser. And there's your outdoor fan motor, also common run start. And there, see this section here, the control compressor contactor coil. All right, next. What's wrong with this picture? Okay, This is actually, this diagram was from an actual unit. Okay, I removed it out, made a photocopy, because even on the field there's mistakes. That's why you need to learn, Okay, what's wrong with the unit is the crankcase heater right here. It is in series. It right now will never come on. Look, contacts are closed. It should be crankcase heater should be always on power before. Crankcase heater should be up there. Okay, as you can see in the diagram, it's done properly there, but not here. Next. The Right now the transformer will never come on because it should be on the L1, L2, not T1, T2, and it should be up there. Transformer, there it should be up there. Transformer power should come L1 to transformer, and here in this case L3 to transformer. Okay, for the students, I have stuff that can do transfer from ladder to pictorial. Okay. Thank you. This is just an introductory. Diagrams, large diagrams have numbers on the side. Each number says you have a coil here for a relay and numbers next to it. The numbers is the lines on the load circuit saying what's open, what's closed, when it's underlined, when it's not. No boss is going to send you to a 20-ton, two-stage cool, three-stage heat unit from the first year on the job. Slowly, you learn how to work the big stuff, okay? Because I have worked in bigger units where we have the power coming in 460, controlling my two compressors, two condenser fan motors, and the blower, and then voltage drop down to 120 volt, and that controls something else, and then I control some dampers and stuff, and then 24 volts. So thank you. Any questions, please contact me and make sure you leave a review. Peace. Have a good day. Thank you.